I have these 4 resistors right here, and the question I'll start out with is, what's the equivalent resistance? Well, it is actually impossible to know what the equivalent resistance is given how little information I have right here. Because it really depends upon equivalent resistance between what 2 points. Where are the leads? Where are we putting the probes of my ohm meter? Am I putting them across here, across here, across here? So let's take, or here. I guess we have lots of choices here. So let's just take a couple of choices. So if I look at that, let's say that this is where I'm putting my probes. These are now in series. This one is not. So what I'm left with is I still have my 1 ohm resistor right here. And then the other ones, because they are in series, because any current flowing this way has to flow across the other 2, I just add them straight up. So that's 9 ohms. These 2 are in parallel because they have a common junction at both ends. And so we end up with my equivalent resistance for this situation is 0.9 ohms. If I took a look at the situation here, so let's do it again. So I've got my 1, these are in ohms, 2, 3, 4, and that. And I put the probes here and here. Well, these 2 are in series. Those 2 are in series because any current that's flowing across here is going to have to flow, anything that flows through that will have to flow through that. So this is the equivalent of having a 3 ohm resistor here and a 7 ohm resistor there. And those are in parallel. And so the equivalent resistance is 2.1 ohms. And so it makes a huge difference about where the probes are. Now, usually we can sort of offset that by throwing a battery into it. So instead of putting just lines like that, which is often a technique that's done, we could have also done throwing a battery here. 1, 2, 4, 3. And my drawing is getting worse and worse as I go, but hopefully you can catch what's going on here, the fact that this and this are the same thing. Let's do a complex drawing. So what is the equivalent resistance? Here, I have my battery here, so basically I have 2 junctions. My probes basically are being put here and here. Now recognize that in this type drawing right here, that the wires themselves are providing no resistance at all. That any resistance in the wires is already bundled into what I have right here. So this right here is just one giant junction. There's no resistors in between. That's a junction there. We have a junction here. We have a junction here. So resistors that are along the same path between 2 junctions are in series. So I have, these are in series right here, so I just add those straight up. So that's the equivalent of 11 ohms. I don't have anything else in series. And so what I'm going to do is I'm going to redraw this, except I'm now going to make that substitution there. So I have my 1 here, my 2 here, my 4 here. I'm just going to clean this up a little bit, put the junctions, sort of combine the junctions into 1, 11, or combine that whole thing into a single point. Then I have this 3 here, 7 here, and then that comes off. So now, well, I see that these, I have a junction here, 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 and here. These 2 have a common junction on each end, so these are in parallel, so I'd add those in parallel. And so 1 over 4 plus 1 over 11 is equal to 1 over my equivalent resistance there. And so I have 4, 11 plus, so this is my equivalent resistance is 2.93 ohms. I have these also are in parallel. I guess I could have noticed it over here, but these are in parallel, so I can add those because they have a common junction on both ends. So 3, 7, and so this is 2.1 ohms. So let's rewrite that now, just simplify it down a little bit. So I've got my first junction here, so I have my 2, I have my 1, and then I've got this 2.1 over here, and I have a 2.93 repeating over here. So this is what it's come down to. These are in series, so those will add together as be a 3.1. Those are in series, so that's 4.93 repeating. So now I've come down to just a very simple 4.93 repeating ohms, 3.1 ohms, so 4.93 repeating, 3.1 inverse plus, and so I end up in the end with a total equivalent resistance of 1.9 ohms. Now let's take the exact same problem, except now let's make them capacitors instead. So let's draw this up, this absolutely spectacular drawing here. So capacitor. All right, so what is the equivalent capacitance? Do notice that I have a, if you do a comparison of the two, I originally had the battery facing the other way, and I thought, well, let's keep the battery in the same direction. It really is irrelevant, the direction of the battery, when I'm trying to find the equivalent capacitance. It will make a difference in terms of, you know, where the positive and negative charges are on the capacitor, or in the first case, if I switch the battery, the direction of the current flow. Well, current flow here as well. But that's why that little mess up is right there. So these are in series. So for capacitors, that's 1 over 5 plus 1 over 6 is equal to 1 over my equivalent capacitance. Sort of the math is the reverse of the resistor. And so I end up with my equivalent capacitance is 2.7272 repeating. These are in parallel because I have a common junction on both ends. And so because they're in parallel, those will just add straight up. So that's a 10 farad capacitor. So now I've gotten that narrowed down a little bit. I can clean it up some. So I have my 2 here. I have my 4 here. I have my 2.72 repeats there. These are all in farads. And then I've got my 1 farad right here. And then over here, I have my 10 farad. Oh, and this shoots off like that. Those are in parallel, so I would just add them straight up for capacitors, so 6.72 repeating. So I now have my 1. Sorry, I could have done this last step, but I can do it this step. 6.72 repeating. These are in series, and so this is when I add the reciprocals. So that combines to give us a 1.54, 1.6 repeating farad equivalent capacitance. This adds up to 0.90 repeating farad capacitor. And so now these are in parallel, and I would just add them straight up. And so we end up with, in the end, with a total equivalent capacitance of 2.45 farads.